this, pull up here. Okay, this one is live. YouTube is also live, it seems. Okay, good. So yeah, welcome. Let me just send Luke a message because I always forget. Okay, put my phone away on a charger. Okay, let's see. We're doing Advent of Code 2024, day 23. Let's switch back to the normal desktop. Hey Marte, good evening, welcome. How has it been? You've had a few days off of work now, right? I think you finished 2 days ago. Have you been enjoying it so far? Hey Nineberry, welcome. Missed you yesterday, but I checked out the code after the stream. Can imagine with all the days coming up now that it must be hard to find time to even watch all of these. So I know I'm out of the door tomorrow with family, visiting other family. So I don't know if I'll be able to stream tomorrow, and if so, it will probably be kind of late. So excuses in advance if I don't make it tomorrow. But yeah, I'll do my best and see what we can do. I hope everybody's having a nice time, nice end of year. Still, let's see, Amarte says, not really, I've been debugging my work project today, was crashing, but only while on the OBS recording session. So yeah, oh, that's interesting. Nineberry says, I'll be away for family meeting as well tomorrow evening. Yeah, I can imagine most people will be visiting family these days now. So no worries. But yeah, it's weird that it crashes only while under OBS recording. Is that because of limited system resources or? Interesting. I've just got a glimpse of today's issue. Looks interesting. First I thought are those language codes, but I see something about the LAN party. Was today fun? I haven't heard much about it yet. Covering my nose with foam. I made a cappuccino. Yeah, this side is more fun. So there's lots of foam in there. Okay, an interesting one. Okay, let's hope it's not too hard. Yeah, I guess we'll just start reading it today and see what it has in store for us, right? Amata says, turned out yes, Unreal crashes when it fails to allocate memory for images, but only for UI. If for world objects, it would just fail to load and show blur. If for UI, it will crash. Okay, interesting. Is your machine a bit under spec to run both at the same time? How much RAM does it have? Meanwhile, I think I'm going to start reading today's issue, but feel free to continue talking about it. It's always interesting. Day 23, LAN party. As the historians wander around the secure area at Easter Bunny HQ, you come across posters for a LAN party scheduled for today. Maybe you can find it. You connect to a nearby data link port and download a map of the local network, your puzzle input. The network map provides a list of every connection between two computers. For example, and here's a list of all the connections. Each line of text in the network map represents a single connection. The line KHTC represents a connection between the computer named KH and the computer named TC. Connections aren't directional. TC-KH will mean exactly the same thing. LAN parties typically involve multiplayer games, so maybe you can locate it by finding groups of connected computers. Start by looking for sets of 3 computers where each computer in the set is connected to the other 2 computers. In this example, there are 12 such sets of 3 interconnected computers. If the chief historian is here and he's at the LAN party, it would be best to know that right away. You're pretty sure his computer's names start with T, so consider only sets of 3 computers where at least one of the computers' name starts with T. That narrows the list down to 7 sets of 3 interconnected computers. Find all the sets of 3 interconnected computers. How many contain at least one computer with a name that starts with T? Okay. Sounds interesting. This has 12 gigabytes of VRAM, not enough it seems. You have a 3060 then, probably? So it's a VRAM issue. Okay. How heavy is OBS on VRAM? I thought that would be not that bad. Yeah, let's see. This is a test case. 12, 7. Yeah, okay, that was it. Let's grab the code here and create a file for today. Just gonna keep the Solution Explorer on the side where you can't see it because it's not that interesting anyway. 23, and at least more code and more room for zoom that code. So this is our day 23. Let's also make sure that we run this day when we run the program. We have a test input. Let's switch to the 3-line format like this. Yes. This answer was 7. We have a cons char historians computer starts with equals T, lowercase t in this case. Amata says, I thought so too, but 4K recording takes some resources, it would seem. Anyway, thanks to all of that, I haven't done part 2 today. May have to wait for actual holidays. Okay. Why are you recording in 4K, by the way? Is that with a special reason? I mean, I don't know. It probably makes sense if you're doing actual recording rather than streaming. Because for streaming, like 1080p is probably still best. But yeah, I can imagine that 4K for like having product shot of product videos is better. I've actually looked at like it's interesting when you use a real-time engine like Unreal or Unity and you actually use it for like high quality renders. So that's pretty fun to set up where you just like, okay, I want to make it 60 FPS or 120 FPS in just the best detail and not try to spit it out in real time, but just generate the frames. It's a fun, whole other fun way to work with the engine. Martin says it's not for public, so you want to show the best quality possible. Yeah, can imagine. If you have a secondary machine, you could also just like do what most streamers do when they want to stream at the best quality and not have the streaming itself impact performance in game and cause lag spikes. They just use a secondary PC and have like a pass-through of the video to record it on a secondary machine, so the one machine doesn't influence the other. So having like a dedicated smaller rig, and it doesn't need to be that advanced. I think you can probably go with a way older graphics card as well, just to have this stream capture if you wanted to. Let me think. We were doing this, we had the marker, we had the answer for P1. We need to find internet connected computers. Int find computers connected count is 3. The name is a bit bad, but alright, I see. Yeah, we have recording hardware at the office, but some people try to record at home and raise alarms. Can't imagine. Just tell your boss you need a 4090. Can't help it. It's double the VRAM, you know? And most people, like, if they don't have the newest of the newest stuff and don't have a 3060, they might even have only 8 gigs of VRAM, because that for some reason they kept doing that for a long time. The Downloadram.com, yeah. I still have a bunch of 3060s here, actually. Let me see. You can. I just have like stacks and stacks of them still. Just in arm's reach. And even have a 3090 still here that's not in my machine. Should probably use that sometimes. But yeah, that's why I picked up on the 12 gigs of VRAM. Like, there's only one affordable card that has that. At least it used to be. So let's see, what were we doing? We're doing the mapping here. So we do input 2 lines, and then we do select split like this as value tuple. So now we can do for each string like this. We can have a dictionary of string with a hash set of string, network map, blah. If not network map, try get value A out var A connections. A connections is blah. We do network map.add like this, and then we do A connections add B, and we do the same inverse. Hey Luke, welcome. Marta says, throwing those GPUs would seem like showing gold bars a couple of years back. Yeah. We do the inverse here. We call it B connections, B connections, B connections, B, and then B connections add A. Okay, so this sets up a network map. Now we need to find a network map where x dot value dot count equals 3, and x dot value dot contains no, actually this needs to be 2. X dot value dot contains any historian blah like this. So let's do this like this. We do x of keys 0 equals historian. That's a JavaScript equals, or like this. Boom. So we do this is actually P1 already. So let's do this, make this global and accessible. And now we do network map is this, and then for P1 we do this count. We can just make this count actually. So this should be P1. Sure. Let me do, because my authentication expired, so let me just go and grab the new cookie. And now I kind of want to use my code, but it will spit out my cookie in plain text, so I won't do that. Open folder, blah, bin, debug, 9, session, sure. Let's open advent of code, grab that session. So this was the perfect time to actually flex my my program. And now I can't because I didn't clean it up so that it won't display my session. I will probably make sure to edit it and then show you tomorrow or the day after or whatever. Let's see, where is my session cookie? Here. Boom, saved. So yeah, let's get back. So now it should work. Still bad request, wait. I'm in release mode still. I need to do this in debug mode because I haven't updated the thing in release mode. Let's see. Okay, P1, 0. Okay. What does network map hold? They all hold 4 connections. So that is interesting. They need to actually share more than 1 connection, is what I just realized. Yes. Let's see. So let me see where this needs to be at least 2. This one is for later. Actually, no. This qualifies the sets first. Let's see. And network map. How do I call this? Because for each value you need to find that it maps to the to the inverse one as well. So you need to do x as value dot count y dot and this one is the list there. Today was weird. P1 takes 9 seconds, P2 runs in 3 milliseconds. Yeah. Interesting. Let's see. Y, and this would be network map like this, contains x dot key, I think. Set next statement. Still 0. Okay. I should probably do some filtering first. Let me see. Because we want this network map where X, and I think this one, no, this is not correct. Because you need to know that that pairs of them match to one another. That's an interesting one, because we can start by just finding every group that has at least 2 peers, and then make sure that within that group you find something that has at least that number of connections. So let's see. You want for each one of these, let me just write it simpler. For each var x in network map, right? You have the key and the value. So you want to know that for each, like you have a hash set of string. Computers is x of the value, x of key. And now you want for each one of those to make sure that they map to at least 2 of those. So you do network map where x so I could just do not computers select or where. So this would mean network map x not this intersects with, we don't want that, produces a set of 2 sequences. Okay, what does this one do? Why is there no, why does this one have IntelliSense but the other doesn't? Is it this? If this, actually I want to have this mapped var interconnected is this, but they need to map to all of them, because this still doesn't mean I think I'm trying to be too clever here. Let's be dumb first and then figure out to be clever later. We do for each string computer in network map. Dot keys, right? We can actually call this A. We can just do this ABC and have 3 nestings. Do I just need to... I need to have the permutations of those and then check. So it would be var peers. Let's call this computer again. Peers is network map computer. I need peers.get permutations to false for each. think I should make this in a way that I should probably do this in a way that I make this into a function that I order these, that I sort them and then have them as a value tuple, as a key, so that I can cache the answers here, so that you don't do the same work over and over again. So let's see, string A, string B, string C, get key, string A, string B, string C. This would be is new blah. So I can do A, B, C, parts sort, and then I can do return parts as value tuple 3. So this would make a sorted key. And then I can also do int get peer count like this. I can just do string A, string B, string C, string key, var key is get key ABC. Let's have a dictionary of that key type. If peer count, try get value, key, count, return count. And then we need to do the actual work. Boom, 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 boom. So now we need to do, for each one of them, validate that the others exist. So we do a network map. A contains B. Actually, it's yeah, let's do it like this. It's fine. G says my P2 took so long I stopped it, but I was still lucky enough to get the right answer. Okay. Let me see. Also, good evening, G. Welcome. And count is 0. If count let's see, A needs to contain B, B needs to contain A, yeah. Actually, yeah, we just want to, I can do this like I enumerate. IPCs, and I can do for each var combo in PCs that get permutations int peer desired peer count, but that would only work for 3 right now. Never mind. This. I also need to do a variant that lets me put in a value tuple. Get key this. Get key like this. This also now needs to do like an IEnumerable of that key with the PCs and probably need to do it like this for now. If the account try get value key out of int count and count is, no, I just need to do this. If count is 3, yield return key like this. Else count is 0, and then we do if network MAC contains key dot A contains key dot B and key dot C. That's one. Now we need to have the other variants. So A actually, I think this just needs to hold a boolean because I don't know. Bool is 3 is 3. Boom. Let's see. Because this, you just need to check 2 things. Sorry if I'm a bit all over the place, but yeah. Basically, we need to check if A has a connection to B and C. We just need to check that B and C also connect to each other. So we need to check like key.B contains C, and then it's fine. Because they're inverse connections. So if A is connected to B and C, then we check that B is connected to C. And if these are all true, we can do peer count add key true. So we can actually do blah. Is 3 is this. And then is 3 we can yield return key is 3 like this. Boom, 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 boom. So this has a way to look up these 3 now, I think. And now I need to make sure that I check all of them and deduplicate it. So now I can look to all the network maps, and I need to do where x.value.count larger or equal than 2. In this case it's all of them, but I want to make sure that we just do it like that. So any PC that has at least 2 other connections, we can take them. We can do select x get peer count value comma x of key. So this is the combination, and it's probably a select many, because this one will return all the the keys. So far, keys of 3 is this, and I can just do a distinct probably, or I can just do a hash set, and then we use this key. Since the keys are sorted, that should be fine. Com interconnected 3, and then I can do like this. That will deduplicate it as well. So yeah, and then we need to make sure that all of those combos var with T is interconnected, come on, interconnected 3, where X at A starts with historian's computer. And this becomes 3 ORs basically. B, C. And I might want to do that filtering and another location, but it's fine. So now we get P1 is with T.count. And we can probably also write that out to the console to see what we come up with, but that's fine. For each if test, for each var 3 in this console.writeLine write line. So this is T3.A, B, C. So let's see what this does. Lots of coding, see if this works. Boom, okay, and it worked right away, so that's fine. Codeta, Cocata, yeah. So it seems like this is working. So let's do this for the real input. False. Sorry, it took me a bit to wrap my head around it and build it. So that is still pretty fast. 1419. Woohoo! Gold star. Nice. And I think it was pretty fast. I should do the starts with. Did I do starts with? Because this one should be like this. Woohoo! Star party. Thank you, Nineberry. So this one will be a lot faster because with the string compare ordinal thing, right? Yeah, near instant. Ame says, that was really fast. Thank you, my dear. Mama Plays is my wife's account, but my eldest daughter is watching, so. Hi dear. She's not used to me finishing part 1 so quickly, apparently. So yeah, I'm happy with that. Let's have a sip of coffee before it's cold and then start to read part 2. Let me save actually the answer for part 1 so that it will step over it. It was 1419, I think, right? Do I have it on my screen? Oh, no, I don't want to start Spy++. 1419, yes. Continue to part 2. There are still way too many results to go through them all. You'll have to find the LAN party another way and go there yourself. Party! Since it doesn't seem like any employees are around, you figure they must all be at the LAN party. If that's true, the LAN party will be the largest set of computers that are all connected to each other. That is, for each computer at the LAN party, that computer will have a connection to every other computer at the LAN party. In the above example, the largest set of computers that are all connected to each other is made up of 1, 2, 3, 4, yeah. Each computer in this set has a connection to every other computer in the set.
The LAN party posters say that the password to get to the LAN party is the name of every computer at the LAN party sorted alphabetically, then joined together with commas. The people running the LAN party are clearly a bunch of nerds. In this example, the password would be Korekata. Okay. Okay. So the largest set of interconnected ones. I wonder. If I can make this better. Because I already have like the permutations thing. There's an algorithm for this apparently, but I just did my own thing. Well, that's always the best, right? To do your own thing. Like, I think I could zip over this and then count them. Let's see. If I do just an hash set of string get pair count. I think if I do this if I do a get key for 2 as well, I can also make this better. Actually, let me think. Combo as value tuple. So this will give us an item 1, item 2. So we can do if key.item1 compared to key.item 2. I can just say key parts. This modifies, right? I think. Yes. Okay. So now we have like this. It's a lot of work just to sort them. I can probably do it inline, but it's fine. This. I can also then have the Nineberry says, I also did my own thing, then afterwards Googled and found the algorithm and remembered having learned about it at university, but that was more than 20 years ago. Yeah, I can, I feel ya. Actually, this is probably so fast that I don't even need to bother with this, but it's fine. Maybe not. It's good to have them sorted so that it's always represented in the same way. But I don't need this cache because the dictionary is probably fast enough. So let me see. Get peer count. this is every combination of 2. Let's see, int count is 0. Let me think. Because I can do key network map key dot A contains key dot B. Actually, can I just take every pair and then count how many times each one of them occurs? Isn't that the key here? Because if I get all the permutations and then I think that's okay. Let's see. NK CSS ASC without speed. What? G says nice. Star still need to look up how to use emojis. Yeah, you can just, yeah, you do like a colon to trigger the lookup. There needs to be either at the start or no character before it. So colon NK CSS and then you get the 3. So let me show you. Colon NK CSS and then you get them. But let's say that you have this one in there. If you now do NK, it won't, sometimes directly after it, it won't trigger. So I've had that before where I'll put like an emoji in there and then I do NK CSS, see? So it depends on what you have in front of it. So when in doubt, do a space and then the colon NK CSS and then you get the emojis. So yeah. Let me see. Yes. So basically I get all the combinations of 2 and for each time they match I add each one of them to the to a count and then I just see which one has the best count probably. Like the lowest common count is the amount of interconnect, no? Leek says last year or the year before there was a puzzle like this, wasn't it? Yeah, probably. Let's see, if I do dictionary, if I do string int and I do connection count blue, and then I can do if this, I can do connection count, if not try get value. I should probably initialize all of them. It doesn't matter. Add or try. I can do try add. Attempts. Wasn't there like a logic you can do if it didn't work? No, okay, it's fine. If not, contains key, no. If not, try get value key dot a out int count a count is 0, and then we do connection count key dot a is plus plus a count, like that. with the reference type, you don't have to do it like this, but this works. Why is it complaining? Let me stop running for a bit. Error list, not string, again doesn't exist. No, I say if it doesn't exist, I set it here. Ah, okay. There were some extra accolades there. Okay, let me see. Same for B. No spoilers on day 25 part 2 here. Yeah, that that's always if you get all the stars you can do part 2, which I sadly barely had the pleasure of doing. Let's see. Would this be the max count? No. I should probably branch this and then do a version with and without. So my idea is yeah, that was, I remember that one. There were tricks there as well. I want to go to each permutation here, each combo of 2, and then if they don't exist, I should probably what do you call it? Branch off into finding the ones that don't have those. So I would treat this like a queue of hash set of string. Something like this, and I can do while queue.count log 0, and then I would do this thing, but I would break if it wouldn't I don't care about this at all. Do I? No. Network map. If it doesn't contain, I want to create 2 versions. So let's see, hash set string PCs network. Yes, q.dq. And we want to get all combinations of 2. And we don't care about all of this actually. So we have key.item1 and key.item2. If they don't match, we do q.enqueue. Like this. This would be network accept Produce a set difference. Use the default. Except key that item 1. I can do var hash set string branch A branch B. I can just do like this, and then I can do branch A dot remove key dot item 1. Branch B that remove key dot item 2, and then I can do q.mq branch A, same for branch B, and continue. Actually no, I need to stop here. Bool is valid is true. Actually, I can just break here. Break. And then I can do if is valid. Then I can return it. I can just do return network in this case. I can just return the smallest or the largest set of interconnected peers. And here I can do return blah because nothing works. So I think get largest network. This should give us the largest network giving a set of interconnected things. And we might do a bit too much work, but we'll see. So for part 2, I should probably use the part 1 answer to find more, but it's fine. We do network map, select X, get largest network, X of value, X of key. And then that, yeah, order by descending, count first, bar biggest is this, console, that right line, biggest sort, and we can do biggest map, biggest of count, and then we do string.join, string.empty, biggest, and we could probably have used like a dictionary to attack the input and see what it does, but yeah, let's see if this does something. That should give me, said that a lot today. Okay, let's see. Part 2, 0, okay. Biggest map, 13. Am I running the test input? Let's see if that works. Comma separated. Join together with commas. Let me. How could I forget? So this one will be comma. Comma. Set next statement. I thought it would spell out something nice. Woohoo! I didn't even try the test input, so confident. I was there. Yeah, that's nice. And another party on the screen with lots of stars. Thank you. Amata said that was fast. Well done. Thank you, everybody. Nah, it's fine. I wish I thought of this approach for part 1, because that would have just made things probably easier, but I like the thing that I came up with. Both parts run fast. Yeah, I like it. I should probably just set 13 as the answer here. G says, yes, my alternative network solution for part 2 is like 20 lines. Nice. So what I did, was that part of the algorithm that people use, or did I come up with something myself? I could probably still map like the combo out as keys sorted, and have a cache there. It's very similar, I think. Okay, cool. Just for reference, I wasn't taught this algorithm. I came up with it just now. So I may have told this before, but I have like zero formal training with programming. I'm self-taught, autodidact. So. Tapco Wild says, Bron Kerbosch, this is what's assumed to be used. Oh, okay. But no wonder the algorithm comes from the LANs. Well, I wasn't taught this, I promise. I came up with this myself just now. Let's see what people said in the Discord. Boom, boom, boom. That was... Multi-threading is cheating. No, it's not. Let's see. AOC for today. G says, I've never heard of it until today. Well, a few years ago, I never heard of Chinese remainder theorem either. So there's always something new to learn. There was like Floyd Warshall last year as well. So there are so many cool algorithms that are yet to be explored. So. Dijkstra A+, yes. Oh, Dijkstra is Dutch as well. Let's see what Nineberry did today. Nineberry said, we learned about clicks and this algorithm at university. Okay. Build network. Okay, let's see. Part 1 network, find clicks of 3. And where any has the first character T. Yes. Find biggest click Dutch way. Nice. I should probably cue like the Wilhelmus, but I'm afraid F1 fans are traumatized by that. So maybe I should just do like that guy. Let's see. Build network. Freeline info. There's the parsing at edge. Okay. Find biggest click, already handled, max. Size 3 clicks, find clicks 3. Yeah, the snollebolletjes. Let's see. I actually should check what Spotify is playing, because I usually do stream beats just because it doesn't get me copyright strikes, etc. But I think like a few days ago, I forgot to stop it and it was playing like Billie Eilish and stuff like that. So I immediately got all sorts of emails from YouTube like, you're playing copyrighted music. Let's see, already handled max click, try grow click, okay. Try grow. Candidate select many, this except that, okay. For each candidate node. Ah, okay, you just try to see if you can. Okay. Even though it's like it goes back to high school where those groups forms, those are called a clique as well. So like it's stuff that sticks together, right? Interconnected. So it's in Dutch it's a familiar word. So I'm sure there's analogous names in foreign languages as well. Nineberry says my attempt is basically a tree search culling already seen node. Yeah, but like this one tries to start from a smaller group and tries to expand it, and I do it the other way around. I take I have already mapped out all the individual pairs, and I just take each computer that's connected to, and I should probably have I should have probably looked at the PC that has the most direct connections and then go from there. So I could probably further optimize this as well, because you need to find the biggest one. You can just sort by a PC that has the most individual connections, and then try to build out of that, and then see how big you can get, and then you can also eliminate every PC that has less connection than that already. And so yeah, there's still steps to optimize. Trying to find biggest click Dutch way. Bronkerbosch, there's 2 hashtag clicks, okay. Nineberry says, yeah, the input is nice because the node with the most connections is also part of the biggest click. Yeah. Every computer has 13 connections. Okay, that takes away that. Let's see. Current members, potential additions, excluded. And then clicks, okay. If potential addition. Okay, I will need to read up on this because it doesn't click right away, but I believe you implemented a known algorithm for this, so that's fine. Find clicks for node, as string, make network string. Sure. Find clicks for node, find recursive. I assume the make network string is just yeah, a sorted list of the names. Sure. Luke says, I misunderstood the puzzle at first. I thought a click couldn't be connected to another computer. Okay. Luke, took a while for me to get the correct algorithm for P2, and I think there are inputs possible where it will fail. P rundowns in 19 seconds, P2 in 33 milliseconds. Okay, let's see what you did. P1 for each link PC. First, last. If A is not equal to B, sure. Link PCs are G says, so when I found a size 13 clicker, just stopped the program and entered the answer. Oh yeah, because that's already the biggest network. Yeah, makes sense. For each piece. What does this do? So it has A and B, but not A. What does that mean? PCs. And this is one where it has A but not B. Okay. It means every computer on that list except the one you're searching for. I did it that way too. Ah, okay. Ah, okay. Sure. Okay. P2. Let's see. First, last. Thanks for explaining, Michael. Yeah. If it's not there yet, add it and add itself to it. Okay, you add the thing itself. Yeah, I always do unions where I have the key added to the value, but maybe it would have been better to just have the thing be part of it as well, so that you don't have to concat it every time. Nightmare says longer variable names wouldn't actually slow down the execution of the program. Nope, just the interpreter / compiler. But that's all abstracted away once it runs. PCs with links. So yeah, that's that. PC link A at B, sure. PC with links, all order by value.count. Okay. All linked is true for each. Okay, you mean that you, and that's what G said, like the max connection is 13 and there is a click that actually has all 13 connected, so that's why this is the quote unquote naive approach, and it just finds one that has all linked. So yeah, makes sense. I think like with Advent of Code, using some of those presumptions is fine. Like there will always be people. All linked isn't used? What do you mean? Ah, I see. Isn't there a break here? Let's see. For each TST interconnect intersect. P-link with intersect. I think you can. Oh, you don't want to modify the things in place, so you create a new one. Yeah, okay. You could use the like biggest chain equals the angle brackets thing there, but okay. And what was the issue here? Because you said it might not work for everything. Value to hash set. Okay, because this will just keep producing like the union or the intersect there. If T contains could make it fail if the what was different? Ah, the sequence. Really? Yeah, I think it's fine. I don't see the issue yet, but maybe I'm missing something. I think Bruce posted a Python solution. Let's see. I was already scrolling up. Okay. Network X. Okay, let's see. That's kind of like having a helper that says solve day 23 part. Nah, I'm kidding. Let's see. What does this do? NX graph. Add edges from. Okay. For line inliner. Okay. Sorted X find clicks. Key is LAN. Okay. I have a normal version too. I was just interested in what it even was. Yeah, there are many useful libraries in Python that solve lots of complicated stuff, but they exist for other languages too. I think the only external library that I ever used in Advent of Code was when Priority Queue wasn't part of the .NET framework yet, and I used a third-party library for a priority queue because I didn't want to write one myself. Shame, I know. That hardly ever happens. But yeah, I think other than that, I don't use any external libraries. Well, other than like Newtonsoft JSON, but I don't think I've even used that. So the rest is all just base library stuff and my own extensions. G says, I also used NetworkX today for the very first time too. Yeah, well, if it's easy to add, and why not, you know? But I must say that I think it's cool when you find a way to solve it yourself, but like when you know and recognize a problem and you know there's a utility that does it for you, I can understand it. I feel happy that I found a way to do it, and I probably adapt this into a general version that I can now add to my extensions library to use it in the future. So, like, I wrote the permutations thing a few years ago, and it's been coming in handy so much. Let's see. I solved it myself first too. Yeah, okay. Let's see. I was still reading clicks, sorted, find clicks. Yeah. Tuple sorted comb. Okay, for first include make combinations. List 3. Okay. Someone for the part 1. And then you get the last. Nice. Let's see, what was the normal version? This isn't much longer though. Uses 2-pointer in normal version. Okay, let's see. Three computers set values is that for k values and list connection items. So this is the like every key in the computer list. You hard code the list there. Okay, that's fine. I make 2 dicts with 1 list to iterate and a dict with set to search. Yeah. Let me see if I can understand it. So this is the key. This is all the connections that it has. This range though. What happens when this goes out of bounds? Or does every... I didn't check the inputs, so I assume like everything has 12 connections then. They're all length 13, yeah, okay. For J in range I+1, so this is all the combinations, so you start at index, this is how you get all the combinations. Firing set connections. 3 computers add. Yes. If current set is subset. I said earlier, very nice properties this input. Yeah, yeah. Hey, Future Highway, welcome, welcome Raiders. Hello everybody. Welcome to the stream. Hello. Just showing off something I made. I'll put it away. Yeah, I just finished Advent of Code day 23, and I was going over some of the submissions of people in chat. Did you do Advent of Code as well? And if so, which language? How did it go? Always nice to hear from fellow streamers. So yeah, welcome Raiders. I did it in Rust. Rust is a very popular language. I think it might be, after Python, one of the more popular languages to do Advent of Code in.
Did you like today's? Did you have trouble with it, or did you know the algorithm, which I was told was invented by a Dutch guy? Let's see if I scroll back. Bronkerbosch. Were you familiar with the algorithm, or did you come up with something yourself? Two Dutch guys. Ah, yeah, my bad. It's a hyphenated name for the inventors. Okay. Thanks for adding to the info. Let me just drop a follow to Future Highway to make sure I check you out next time. Let's see, it was okay. I didn't know the optimal algo until a user told me about it once I had a solution using backtracking. Okay. I wasn't also wasn't familiar. Thanks for the follow. It's appreciated. What I tried to do was, let me see. I first had just a hard-coded thing to find all pairs of 3. I just coded it out. I had a way to create like a sorted key for the 3 computers, and then just checked all of them against each other. Because I wasn't aware, I didn't know where part 2 would take me, so I was like, okay, let's just code it out and see where it goes and adapt from there. And after that, I wrote this function to basically try to find the largest network that takes like the interconnected list of PCs, and just tries to see if all of them are connected, and if not, it branches off. So if you find a pair in there that doesn't have connection to each other, I branch off into 2 versions that doesn't have either one or the other. And then once we find one that is all valid, we just return it, and then we have a look at which one was the biggest. I learned that the inputs is like they're all 13 length, so once you find one that's 13 length, you got it. But yeah, I didn't study the input too hard. I just coded a way to do it that works with pretty much anything, which I was fairly happy with. So we're looking at Bruce's code right now. Let's see. Did you finish all of the other days, by the way? I still have to go back and do 21 because that was a difficult one. I have a solution. I was very close, but I still need to actually add branching in there to find a shorter path for some of the combinations. You have 2.5 days missing. Ah, okay. I think I still have like a notepad open with to trigger me, like here. So like in my code, there was the test example, and it shows like, yeah, there are 3 valid options, and mine came up with the second. And then I was like, okay, I validate that it comes up with a valid path, and then I put in the answer that the example took to process on. And then again, I got a valid answer, but not the one that the code gave. So I did that again, set it there, and then I arrive at the correct answer. But so I have the mechanics there, it's there, and I also know how to generate all the variations. I just need to now rewrite everything that I did into a way that has like branching logic, so that when there's more than one option, that it tests them out. I try to add like a bias for not for preferring repeating steps over alternating steps. So that solves, like when you have 3 options, it eliminates one invalid one right away. So that's nice, but there's still 2 valid options that it can distinguish against. So yeah, I still have to do that. Maybe there's even a smart way to do it without doing that branching, but I'll go back to it someday. I just don't know when, because yeah, time is limited. So yeah. Let's see, we were looking at Bruce's code here. It's not a lot to look at, but I have a bit of trouble always switching to other languages and fully comprehending what's happening here. If you want, you can submit your code as well, and I'll take a look at it, see what you came up with. We were looking at this current set for Jane range, 2 computers. I don't see that break for length 13 that you mentioned before, by the way.
Bruce said hardcode every move from each position for direction path. Actually, I did something that did like pathfinding for every option. Like my setup, I have like map all as grid location, so I have like helper code that you can feed a grid into. And then it will just, if you don't specify what you want to map out, it will map out every character into a list of all the positions. So I have that first mapped out, and then I do pathfinding for each one of them. Let's see, I think I have, yeah, I think I have like the best, I have logic to find the best between every key to find the path so that I can reuse all of that. But of course, because there's multiple dimensions, it's not a static best answer. Let's see, Bruce says I did recursion. I sent Smara A for numpad. I take that, make it to send it again and again, first element, okay. Yeah, I'm sure there's lots of stuff that you can do, but I still want to, like, when I have some time to sit down and think about it, just to fix it, and because I think we can fix this code. I believe in her. So yeah, that was the code for Bruce. Did G submit something? Don't think so, right? No. Let's see. Yeah, I think that was all the submissions for today. It's still fairly early. No, I'm not in your Discord yet. Ah, okay. You can... If you want, you're always free to join. Happy to have you. Like most of the people that you see in chat are also there, like Amate and Nineberry and Luke. And Bruce says 21 was the hardest day for sure. Yeah, I think so. Hey, hey. Welcome. Yeah, at day 21, there was also the one with like the linear thing. I was just not familiar with how to do it, so it had to be spelled out for me. I couldn't do it without help or looking that one up, just because I wasn't familiar with it. Bruce AM says, or maybe 24 and 25 will surprise us. Yeah, I think I said that yesterday. Like, it feels like this year is easier than previous years, at least the last 2 years. But it was still lots of fun. Or maybe it's because I've been doing it for longer that it becomes less hard, because you've seen most of the issues that you can do pretty much. Jesus, I haven't seen any 3D related yet. Yeah, that was a real... I really liked that. I was really... When I solved that one, where you had to like divide cubes in 3D space and intersections and slice them up, and I was really proud of myself for figuring that out after like hours and hours of working at it. Nineberry says, I don't know if you're already aware, but Discord has streamer mode you can switch on, which prevents you from sharing information you might not want to share. I know about streamer mode, and it's not sure what it... I'm familiar. Boom. There, streamer mode, but I think that's mostly for like notifications and stuff. So now it says streamer mode, usernames are shortened, okay. I think it's also for like, it will mute notification sounds and stuff like that. But yeah. The benefit is that I think it's also links to Twitch. Yeah, I should have done that before, because like I'm at the maximum amount of servers. So it would be good to to promote it more this way. Let's see. Luke says people were complaining about being too hard on Reddit a lot last year. It could be that the creator of AOC listened to this feedback. Yeah, could be. I haven't actually looked at the drop off, like the stats. Do we have the stats? Because I think if you go to like boom, usually there's like like you can see here in day 5 there was like a big drop off, and Yeah, day 21 lowest. $23 to be not that hard. I don't know. That was also day 21. That was hard. I think I don't have, like for 23 there were a few that I didn't complete. Like 21 part 2 I didn't complete yet, and 24 I didn't complete. Because this one, I think Amarte helped me with this one last year, because I still had like an imprecision thing there. G says I had a problem with one of the races problem because I couldn't debug a very large maze. Oh, was that the diamond one, Nineberry? Where it formed like a big diamond? I think I remember something like that. But this one was like where you had to define where it did in past and future. Oh yeah, with the diamond I had like all sorts of algorithms and stuff. I came up with lots of stuff, but I didn't finish it. I think day 21. Test sparse. Yeah, I had like all sorts of functions. No, not that one. Because I had like paint stuff, finding patterns and how to do it, and yeah. Like this file has a lot of code. I don't remember. Oh yeah, like here, expanding object. So I had this whole thing where I would try to find a pattern and have like this monstrosity. I had a lot of fun with it that year. So yeah. Z3, yeah, I remember that as well. But yeah, I should probably still go back. And for this one, day 24, basically the solution worked, but there was a rounding error with some of the large numbers. So I think Marte helped me with this math back then, but there was still an issue with some imprecision causing rounding errors, so there needs to be another way to do this. I haven't revisited back then, sadly. I should probably do that. I actually went back and did, I think for 2016, I did this one recently when I had like a few minutes, because I was a bit frustrated and I just wanted to do something fun for a few minutes. So I went back and did this one. No. Let's see. Simpy is already enough. I tried some problem solver libraries for C#, but they aren't as easy to use as the Python stuff. Marta says, yes, one of the formulas for a line causes overflow in 64-bit. Yeah. So that's, I still should revisit these days and do them, but yeah. I think I'm gonna do, if you guys don't mind, I'm just gonna do like one day for 2016 and see if I can do it quickly. Because I decided not to do any more work after this, so I'll just do a little bit more coding and then head home and get a bit of rest, because it's been very long days. So if you don't mind, I'm just gonna do hopefully an easy one. Luke says, I go to bed, see you guys tomorrow. Goodbye, Luke. So yeah, let's see. Day 7 of 2016. I hope this wasn't a too hard one. Internet Protocol version 7. While snooping around the local network of EBHQ, you compile a list of IP addresses. They're IPv7, of course. IPv6 is much too limited. You like to figure out which IPs support TLS, Transport Layer Snooping. An IP supports TLS if it has an Autonomous Bridge Bypass Annotation, or ABBA. An ABBA is any 4-character sequence which consists of a pair of 2 different characters followed by the reverse of that pair, such as XYYX or ABBA. However, the IP must also not have an ABBA within any hypernet sequences, which are contained by square brackets. For example, ABBA, MNOP, QRST supports TLS, ABBA outside square brackets does not because there's one within, even though blah is outside square brackets. Does not TLS, AA is invalid, interior characters must be different. Okay. Blah 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 supports TLS, access, yeah, even though it's within large. How many APs are in your puzzle input support TLS? Okay, this seems doable. But there are more than one. So they all have 2 of those. Let's see. Let's not worry about that yet. Boom, 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 boom. MizHeadX, haha, I did C# for that year. Lots of regexes. Yeah, I'm actually going to write a parser to just do this one by one, because I think that's fun. So they don't have easily copy-pastable test inputs here. So let me just so the answer for this one is 2. Library says, just pulled out my code. No regexes, but there is an isABBA function. Yeah. Let's see. Let's go to 2016. Create a copy of... this is my day 6 that I made. I think I did this a few days ago. And I wrote helper functions like a max and min per column. Just because, who knows, I'll just make an abstract function out of it to help me maybe another day. So this is day 7. Day 7. And the fun thing is I actually set this up better than other years. And I don't know why I didn't use this format, because I did this later apparently. So the base class also passes in the year that it belongs to. And then it has a general library AOC where all the other stuff is. So I've been extending the thing that's in this class, this solution. So I should probably manage it to take everything that I've written in that extension and put it into the general one. But yeah, that's fine. So the test for these is this. So we do char, const char, bracket open is this, bracket close is this. How do we call, what was it called? Protocol? Oh, these are IP addresses. Okay, IPv7. Sure, let's go with it. Yeah, like ABBA, the band. Swedish, yes. We call these var IPv7 addresses is this. This becomes a string of, yeah, like this. We make them globally accessible here. And bool is valid IPv7 string address. for int I is 0, I smaller than like this, except I prefer mine there, len this. Has ABB outside is false. If also this needs to be and is len -3. If address I equals address I plus 3 and address 2 equals address 1 equals 2 and address I does not equal address I plus 1. Boom, 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 boom. We also need to make sure that none of these are actually angle brackets. Probably do this. Oh, I can now do A, B, C, D, B equals address dot skip I as value tuple 4. I should probably not do this, but yeah. And then I can do A equals D and B equals C and A does not equal B. Because ideally I should probably just keep rotating one out, but yeah. If A equals bracket open or B equals bracket let me think. I should probably actually check this before I do all the other stuff, because if any of those so I should probably just check for that. If A equals bracket open or B equals bracket open or C equals bracket I should probably also know which one so that I can skip over. Trying to see if there's an elegant way here, but it's fine. Outside is false, and then we do I continue. We don't care. if B is bracket open, we do plus plus I continue. We do the same. If C is bracket open, we do I plus equals 2. Outside is false, continue. And then we do if D equals bracket open, we skip over it. I can do this better. Test bracket. Let's see. We do bracket is outside, bracket open, otherwise bracket close. So now we do this. We don't care there. So now we bracket, we compare against bracket, and we do is not outside. Basically we just toggle. Like this. And we could probably make this into a switch. You could do int offset is bracket switch like this. So you do the inverse. You do A 0, B 1, C 2, D 3, and then underscore -1. Doesn't it like this? Constant type of charge. Oh, why? Why can't we just do this? Would be so nice. We can still do that logic. So I can do switch bracket. So it's like an inverse in case A. It will still not like that, right? Never mind. But I can still do not. I can still not do this and just have that if offset larger equals 0, like this. I plus equals offset. So here we can say if A is bracket, offset is 0. Else if offset is 1. Else if offset is 2. Else if offset is 3. Else offset is -1. Like this. So now we know when we toggle from inside or outside within our range check, we just toggle it and we skip over it. And then we get here, if this can never happen, so we don't care. So A is D, B is C, and A is not equal to B. Found alpha. If open, no, if outside has ABBA outside is true, else return false, return has ABBA outside. So this is basically the validation thing, right? Took a bit, and this one isn't really nice, but we'll live with it. Found ABBA, sounds like found a bug. I found a Swedish pop group. Let's see. Part 1 is IPv7 addresses where X actually just count is valid this. So let's set day 7. Set a starter project. Let's see. I will also need to copy the session key here. File Explorer. Let's go to 2024. Bin debug .NET 9 session. And we go up here 2016 bin debug 9. Boom. Yes. Okay, let's try this again. Boom, index was outside the bounds of the array. Okay. So my input to array is probably just a length 3 here. So one of my things is off. It's a char 0. Wait, that's interesting. Length is 2000. Wait. It needs to be this one. And I need to set test to true. What? Yeah. It says 2, and that is correct because it were only 2. I didn't set that. So that is fine. So now let's run the real input. And the answer is 115. Let's see. I opened it in another window. Woohoo! Gold star, gold star. Let's see what part 2 holds in store. You would also like to know which IP supports SSL. Super secret listening. An IP supports SSL if it has an area broadcast accessor or ABA anywhere in the supernet sequences outside any square bracketed sections, and the corresponding byte allocation block or BAB anywhere in the hypernet sequences. Okay. An ABA is any 3-character sequence which consists of the same character twice with a different character between them, such as XYX or ABA. A corresponding BIB is the same character but in reverse position. Sure, okay. ABA, BIB, okay. XYX but no corresponding, okay. Supports SSL but has no blah, okay. How many IPs support SSL? Okay, so we need to find an ABA and a BAB. So outside ABA, inside BAB. Sure. So this will be IEnumerable of string. Actually, I could make this like char A, char B. And this becomes IPv7. This becomes a length of 3. As value 333. So we have A, B, C. same logic here. So we do A equals C, and A does not equal B. If outside, yes, we do yield return A, B, like this. So this gives us every ABA, and then I need to check for BAB. Has BAB char B char A bool. Okay. And this becomes has BAB inside. This. Boom, 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 boom. This needs to be -2, by the way, and the same here. Get ABAs. This needs to be -2. Boom, boom, boom. Yes. If offset, blah, blah, blah. Yeah. So now we can do if C1 is C2, yeah. If not outside and C1 equals B and C2 equals A, return true, return false. Okay. And I think I still need to pre-filter the previous ones. Oh no, so it's separate, so you need to process it again. Okay, so P2 becomes IPv7 address, no, IPv7 addresses where X get ABAs, X, any X has BAB, X dot, this is Y, actually, Y, let's see, this is X, and then it's Y dot B, Y dot A. Boom. And this is actually just count. So 115 was the correct answer for part 1. Let's run part 2. Woohoo! And that's the second gold star. Yeah, nice and easy, luckily. These ones are fun to do. Just like no headaches, just little nice programming experiences. I always say, I also like to just write parsers like this, to just do it easily, instead of resorting to regexes, because yeah, a regex feels like cheating for this almost. But yeah. Oh, what happened? Mizzard X follows you. Ah,
Thanks, Mizet. Thanks for the follow. Appreciate it. So yeah, I think we'll end it here for today and see if we can find somebody else's stream. It's a nice time. It's 9:20 here, so I still have some time to chill with the wife and get to bed a bit early, get some rest, because today or tomorrow will be like a social day, so that always takes a lot of energy out of everybody. So yeah, let's see if we can find somebody else to raid and share the joys of Advent of Code. Let's see. Twitch, Advent of Code. Heading to bed. Thanks for streaming. Yeah, no worries. Thanks for keeping me company again. It's always nice. Adventure of Code in Go. Let's see. And let's also check just the software because... oh, I need to mute that.
Right, let's actually look at it.
No? Okay. I don't think... yeah, there's Advent of Code. Let's see what plus mid says on Twitch. Yeah, let's go say hi here. So thanks everybody. Have a great holiday if I don't see you again. I'll try to stream some more, but I can't guarantee when. Yeah. Ah, this is in German. Maybe good for 9, Barry. I'm just gonna say hi. Let's see. Have a good one and thanks everybody.
Also die quasi nicht lang genug sind, oder? Ich wirklich kein Ton